problems that are similar to what's in the 1.12 TGA. So in this problem, it says that Annalise opened a dog grooming studio in her local hometown. The amount of money she makes depends on how many hours she works. This can be modeled by the function f of x equals 4 times the cubed root of x plus 2. How many hours will she need to work in order to earn $12? So when we do this problem, we're going to start off by setting up the equation. So it tells us that how much money she earns is modeled by this function, and we need to figure out how many hours she needs to work in order to earn $12. So what we can do is we can just plug $12 into this function, right? So it's going to be 12 equals 4 times the cube root of x plus 2. Well, if this bothers you, you can rewrite this. You can rewrite this as 4 times the cube root of x plus 2 equals 12. So now we're going to work on isolating the cube root. Okay, so we want to get the cube root by itself, and this is very, very important. Whenever you're solving cube root equations, you want to first isolate the cube root before you work on cubing and solving for the variable. So what we're going to do here, and what I mean by isolating is like get rid of the extra stuff that's with the cube root. Well, the extra stuff that's here in this case is the 4. So I'm going to divide both sides by 4. And when I do that, I get the cube root of x plus 2 equals 12 divided by 4, which is 3. So now I can undo that cube root by cubing both sides of my equation. And so when I do that, I get x plus 2 equals 3 cubed, which is 27. Now all I need to do is solve for x, so I'm going to subtract 2 from both sides of my equation. So when I do that, I end up with x equals 25. So she needs to work 25 hours in order to earn $12. Let's make sure that our answer is right by plugging back into the original equation. So when we plug back in, we get 12 equals 4 times the cube root of 25 plus 2. So that's 12 equals 4 times the cube root of 25 plus 2, which is 27. So 12 equals 4 times the cube root of 27, which is 3. Okay, so 12 equals 12 does in fact check out. Now let's compare the function g of x equals 1/2 cube root of x minus 1 plus 4 to the cube root parent function f of x equals the cube root of x. How has the function been transformed? So if we look at this equation, so we have g of x equals 1/2 times the cube root of x minus 1 plus 4. And so when we do this, we want to figure out what are the new numbers being added into our equation, right? So we have this 1/2, we have a minus 1, and we have a plus 4. So we're going to figure out what each of these will do to the graph, okay? So what we're going to do is we're going to use this chart that's in your study guide, and I'm going to use that to help me figure out what's going on. So if I look at the 1/2, okay, so 1/2 is a value of a, so this tells me that it's going to be a vertical compression when a is less than 1. 1/2 is less than 1, so that is going to create a vertical compression. Now we have the minus 1, okay? Notice the minus 1 is inside the cube root, right? So that is going to be a value of h. This tells me that I have a shift right when I have a minus sign in my problem. So this is going to shift the graph right 1 unit, okay? And then I finally have a plus 4 on the outside. So that plus 4 is a value of k, and it's going to be a shift up when k is greater than 0. Okay, so this is going to make the graph go up 4 units. Remember, whenever you're using transformations in a problem, you can always use Desmos to check your answers. Okay, you can go to Desmos and type in the parent function. So that parent function is going to be the cube root of x. And then type in the transform function, 1/2. And then we have the cube root, cube root of x minus 1, and then click out of the cube root to do the plus 4. Okay, so notice that it does transform the way we predicted, right? This graph is vertically compressed, that's why it's kind of flatter. It is shifted to the right 1 unit, and it is shifted up 4 units. So now let's try problem 3. So it says find the inverse of the function f of x equals x plus 5 cubed minus 1. So what we're going to do is we're going to use these steps. We're going to start off by replacing f of x with y. So we have y equals x plus 5 cubed minus 1. Okay, so now to find the inverse, what we need to do is swap out the x and y values. So anywhere I see y, I'm going to write x instead. And then anywhere I see x, I'm going to write y instead. So now once I've done this, I need to solve this equation for y, right? Because remember, our equations are usually in y equals something form. So we're going to unpack this equation until we get that y by itself. Okay, I'm going to work my way from the outside in. So I'm going to start off with that minus 1. So I'm going to add 1 to both sides. And when I do that, I get x plus 1 equals y plus 5 cubed. So now I have a cubic term that's by itself, so I can undo that by taking the cube root of both sides. So when I do that, I get the cube root of x plus 1 equals y plus 5. Okay, so now I need to get y by itself. Well, y is not by itself because there's a plus 5, so I'm going to undo that by subtracting 5 from both sides. Be very careful. When you subtract 5, okay, that 5 is going to stay on the outside of the cube root. It cannot combine with that plus 1. I saw a lot of that going on, but that cannot happen because one is inside the cube root and one is outside. Okay, so we just have to leave it like this. So this is going to say that f inverse of x equals the cube root of x plus 1 minus 5. Okay, and that is how you find the inverse. So in part B, it says now graph the inverse function f inverse of x using the equation you just found as the answer to part A. So the answer to part A, so that's f inverse of x equals the cube root of x plus 1 minus 5. Okay, so we're going to graph that function. We're not graphing the original function, we're graphing the inverse. So remember, what we need to do is find at least 3 points to help us form the graph, and we can find those 3 points from Desmos. So I'm going to go to Desmos, and I'm going to type in that new equation that I have. So I'm going to type in cube root of x plus 1 minus 5. So I get the nth root, so I have cube root of x plus 1, and then we do the minus 5. Okay, so let's get some points from here. So if I go to my graph, I can see that at -1, I'm at -5, right? 0, -4, and let's find some other points. Okay, so at 7, we're at -3. You can always use more than 3 points. I just want at least 3 so that I can see that you've correctly identified the graph. So we have 0, -4, and 7, -3. Okay, so I'm going to go ahead and plot these on my grid, and then I need to connect them to form the graph. So some of you are asking, how do I know the shape of the graph? You can kind of figure it out by looking at Desmos, okay? So just kind of zoom out, and then you can see a picture of what the graph is supposed to look like. And so you can use that when you're connecting the dots. I'm not going to grade on artistic ability, so don't worry if your graph doesn't look perfect, as long as you have this right general idea, right? As long as I can see the 3 points, and I can see that you've kind of figured out the shape of the graph. Okay, so that's everything for that 1.12 TGA. Please let me know if you have any questions.